Okay, so for this problem we are asked to integrate x squared e to the x dx. So as always, let's just recall some of the options we have, right? So we can do by substitution, that's do substitution, or we can do by parts, or we can also do by trig substitution, right? So generally try to see which one of these approaches works. So generally the easiest one is by substitution. If you can try that and that works, generally you're good to go, you're on your way. But for this one, we know this is going to be by parts, so let's just go ahead and do that, right? Okay, so the play here is, so first let's recall what the equation is for integration by parts, right? So given that we have something in this form, that's too thick, okay, f of x g prime of x equals, then the integral of this is f of x g of x minus the integral of f prime of x g of x. Okay, so if we have an integral of this form where it's some function times the derivative of some other function, we can calculate its integral using this formula. Okay, so the idea is, how do we decompose this question, so this thing, right, down to something that fits this form. Okay, so for our problem, let's go ahead and say let f of x, so we need to figure out what f of x is, and we need to figure out what g prime of x is. Okay, and we also need f prime of x, and we need g of x, right? So these are the parts of integration by parts, right? And these are the parts that we need to build this. So I'm just going to let here I'm going to say I'm going to let f of x equals x squared and g prime of x equals e to the x, right? So when you're picking f of x and g prime of x, the idea is to pick something that won't make your life overly complicated, right? So we need to keep in mind that whatever we pick for f of x, we have to differentiate, right? And whatever we pick for g prime of x, we have to integrate, right? And in this case, actually, either one of these is fairly easy to integrate or differentiate, because the derivative of e to the x is e to the x, so it's integral, and this is also pretty straightforward, right? But let's just try with this, okay, and see where we get. So f of x is that, so f prime of x is 2x, and g of x is the integral of e to the x, which is just e to the x, right? Okay, so now we have that the integral of this thing, right, is equal to x squared e to the x minus f prime, the integral of 2x e to the x dx, right? So I'm just rebuilding this function with the parts that we constructed, right? So now that we've constructed these parts, right, we can go ahead and try to solve this problem. But we see we have another integration over here, so let's just take it over here, so we have more space, right? Let's just take it over here and say with the integral of 2x e to the x dx, okay, and we just pull this 2 outside because it's a constant. That gives us 2x e to the x dx, right? And you'll see that now this is another integration by parts problem, right? Because you can see that substitution is not going to work because there's not really something we can substitute for it doesn't really make sense, right? So because, I mean, just to elaborate, if we substitute, let's say u equals x, it doesn't make any difference, right? We can say u equals e to the x maybe, but then there's no derivative of e to the x in this equation, so that's not going to work, right? So let's just go ahead, do it by parts. So let's say let f of x equals x, and so f prime of x will equal 1, and then let g prime of x equals e to the x, and g of x will equal e to the x, right? And when we put this all together, again using this parts formula, we get 2x e to the x minus 2 e to the x. Okay, so that's the solution to this part of the problem. So we already have this part of the problem done, right? So now we just have this equals x squared e to the x minus 2x e to the x minus 2e to the x, which is x squared e to the x minus 2x e to the x plus 2e to the x, which is e to the x, and you just pull the e out, x squared minus 2x plus 2. And this is our final solution. Okay, so just get the whole picture for you to see it. All right.